What they lack in size, they make up for in sheer numbers. They're the backbone of more than a third of the world's fisheries. They are small pelagic fish. Small because they're usually less than 10 centimetres long. Pelagic because they live near the surface of the ocean. They're also known as bait fish because just about everything else eats them.
They are the main link, and they shunt lots of this productivity up the food web. If they're gone, then the food web doesn't work, and the other animals don't have food.
The risk is that their dense schools make them easy to catch and vulnerable to overfishing. Each year, more tonnes of sardines are caught than any other fish species in Australia.
Sardines are a classic small pelagic fish. Anchovies and sardines around the world are the small pelagic fish.
Fishing them sustainably means not taking more than the food web needs to survive.
We try to understand the role of sardines in the ecosystem, you know, the importance in the diets of things like snapper, but also the pelagic fish, the seabirds and the mammals.
So you've got to harvest the sardines and at the same time make sure that there's still enough big snapper around.
That's it. And tuna and all the other things. It's an important part of the way the fishery's been managed.
But public confidence in the management of small pelagic fisheries was shaken last year with the arrival of the second largest super trawler on the planet. With ships like this able to stay at sea for months at a time, dragging 600-metre long nets and processing 250 tonnes of fish a day, there are concerns that fisheries can be depleted.
I don't think anybody's really equipped to manage super trawlers. They're boats that should never have been built. I've seen sustainable fishing and it doesn't look like a super trawler.
There was uproar when the government granted the super trawler a quota to catch 18,000 tonnes of jack mackerel and redbait in Australian waters. A storm of protest saw giant factory ships banned for 2 years, pending further research.
This whole campaign undermined the science, amplified the uncertainties and left people feeling really uncomfortable.
So what does science offer to protect the humble bait fish from overexploitation? I've come to the fishing capital of Australia to find out.
Port Lincoln is famous for big tuna, all thanks to a much smaller and less charismatic fish, the sardine. Now, they may be lower down the food chain, but sardines are the basis of the largest fishery in Australia. And I'm getting on board a research boat to find out what we need to know to keep that fishery sustainable.
I'm curious to learn how scientists figure out how much is safe to catch from a small pelagic fishery. Sardines are the best example we've got. Tim Ward has been working on the South Australian government ship Nagarin since the sardine fishery started 15 years ago.
When we found that there was something like 200 or 250,000 tonnes of sardines in this area of southern Australia, that was quite a surprise.
Since 1995, the total allowable catch has grown tenfold to 34,000 tonnes.
It's a mobile fishery. These things have got tails. They move around. So in some years, you know, parts of Spencer Gulf will be more productive than others, which are not related to fishing effort. They're related to other climatic events. So it's a bit of a moving feast.
Twice a year, to estimate how many sardines there are, Tim and his team count fish eggs in the water. It's called the daily egg production method.
We're trying to sample the plankton, but particularly the sardine eggs.
It's no small task. Each of these dots is where they drop the nets, sampling 300 times along transects from the coast out to the edge of the continental shelf.
Over an area of, I think it's 120,000 square kilometres.
That's a lot of steaming around, dropping nets over the side.
Absolutely. So it takes about 2 trips, 14 days each, working around the clock, weather permitting, to sample eggs.
A profiler on the net also measures the temperature and productivity of the water up to 70 metres deep.
So this is like a core sample from the bottom right to the surface.
Exactly, and so we're trying to understand the number per unit area as well as the number per unit volume.
It all comes down to what comes up. A small jar of fish eggs, larvae and other plankton. Back in the lab, they count the eggs. In some samples, more than 6,000 per square metre.
Sardine eggs are quite large. They're quite distinctive from other fish eggs. They're about 1 to 1.2 millimetres in diameter, so really quite easy to see.
For the number of eggs in the water to mean anything, you need to know the number of eggs in the female fish to start with. And that means many happy hours in the wet lab, measuring their vital statistics.
130.
How many of these have you done?
It's past 100,000 now in the database.
The otolith layers in the tiny ear bones reveal the years in a sardine's life, like counting rings in a tree trunk. Tim looks in their ovaries to pinpoint the day they actually spawn.
The egg is released, and what remains in the ovary is called a post-ovulatory follicle, or an egg sac. And by identifying and aging the egg sacs, we can estimate the proportion of females that spawn on any given night, and hence estimate how many eggs are produced per unit kilogram of fish.
From tiny clues like these, other small pelagic fisheries around the world are assessed in the same way as sardines.
The fisheries managers use this in what's called a harvest strategy to set the total allowable catch for the coming year.
However, when it comes to Australia's other small pelagic fish, the numbers aren't so clear. Because they're not as well studied as sardines, their management relies on wide safety margins rather than complete data.
You can't expect to start these fisheries with perfect knowledge.
Take jack mackerel, for example. Their populations are also estimated using egg surveys. But the last time that happened was more than 10 years ago, in 2002.
But the way that these fisheries develop is through adaptive management. So we find out a bit, we exploit them lightly, we find out a little bit more.
Which brings us back to sardines. We're anchored close to the Neptune Islands, setting up for a long night of netting.
All right, hold on the head rope, pull on the foot rope. We can't run a trawl off here, but we can run the gill net, and this has provided the samples for the last 15 years, basically.
Our mission tonight is to catch sardines of different ages with a net of different mesh sizes.
When they're attracted into the underwater light and the surface light here, they get meshed in the gill net. We're aiming for samples of about 100 to 200 fish. You can catch larger quantities of fish, but these are perfect for science samples.
The trick is to be here at just the right time when the sardines spawn.
Okay, let's go.
While we wait, I check out what else is swimming around us.
This is a jack mackerel, made famous because it was one of the small pelagic fish targeted by the super trawler. But compare it to the sardine, which is a small pelagic fish. Jack mackerel are a lot larger and much longer lived.
Unlike sardines, jack mackerel grow to 0.5 metre in length and live for 17 years. They don't really fit the description of a small pelagic fish.
To call it a small pelagic is actually an error. They are longer lived, they will react more slowly, they will be more quickly reduced in biomass if you fish them hard, and they will not bounce back the way typical small pelagic like sardine, anchovies and so on do.
Off we go.
So to be on the safe side, the catch rates for jack mackerel need to be very low.
We'll just bring it up evenly together. Start now.
Tim and his team haul in the final pieces of the puzzle to figure out the size of the sardine stock.
This enough for a sample?
Yeah, this is good. This is plenty. There's some spawning every night, so yeah, about 15% of them spawn every night during the peak of the spawning season.
The catch is quickly sorted for analysis in the lab.
Okay, this is a female with hydrated oocytes. So she would have spawned in a few hours tonight, around midnight or 1 o'clock in the morning. When we count the eggs in these ones that are ready, and that's how we estimate how many eggs are produced in each batch. They're great fish, you know. They're the linchpin of the system.
So they've got to be respected for that.
Exactly.
In the end, this fishery is about taking sardines from the wild to feed their natural predators in captivity. Nearly all of South Australia's sardine catch is used to feed farmed tuna in pens. 7 kilograms of sardines grow 1 kilogram of tuna.
The appetite of the tuna industry for sardines is a voracious one. Each of these frozen blocks of sardines weighs about half a tonne, and it takes 20 tonnes to feed 1 tuna pen for just 1 day.
That's the likely fate of much of the super trawlers' catch: fish food. Based on the experience with sardines, if Australia's other small pelagic fisheries were to be exploited, what kind of research needs to be done?
Exactly the sort of thing that we've done here, where we've really spent a lot of time and money understanding the size of the biomass and assessing it annually so that we can set conservative exploitation rates. We've also gone out there and really proven to ourselves that this fishery at this scale can operate within a healthy ecosystem.
In the wake of the super trawler, there are even bigger questions to consider.
We've somehow missed out on, I think, what some of the people are really concerned about, which is, should we be fishing small pelagic fish at all?